So how's everybody doing? Well, I try to get this to work because apparently classroom is going
I just
slow.
want Deku to get stronger, you know what I mean?
Uh, bruh, Deku's cheater.
Yeah,
I also think I'm an episode or two behind.
probably. I'm like 4.
What the hell are you doing?
I
As
have
she laughs and continues doing whatever it is.
I have iced coffee sitting on my desk, so I'm playing with it.
Well, then mute yourself.
I'd rather not.
We rather you would before I mute you. As she laughs and continues to do it. That was the best part, Deborah.
I was born to be a comedian. What can I say?
Pretty funny, that's for sure. There we go. You said number 10, Thomas?
Yes.
I think so.
Yeah, that's what number one.
Definitely did not do 10. We did 9, yes. So I remember talking about the. Okay.
I could have just said any number. We probably would have gone with it.
Number 18.
Well, I would have started there and checked around to make sure, like the previous problem, to make sure we did
What
it.
are you doing?
Okay, Deborah.
Sorry, it's my dog.
I assumed that it was either one of the dogs or cats. However, we
Yeah, we
don't
took the
need to
cats home
hear it.
yesterday.
Define took them home.
Well, we took mine and Michaela's cats to here,
Define here.
to
Jesus.
Mom's house,
Okay, that's.
because they've been at JJ's.
I didn't know.
Oh. Oh yeah, I guess you haven't been over in a while.
No. You people had the corona. I couldn't come over.
Oh
Okay.
Jesus!
Alright. Number
They're attacking
10.
the door.
Is it closed? Turn your push to talk on, please, before I mute you.
Me?
Yes.
No.
You are the only person making a tremendous amount of noise. You don't know this because you're the one making the noise.
Mom said I'm noisy.
She is. That's why I asked her to put on push to talk or mute.
Oh, I thought that was Deborah who walked far away to say something.
They sound very similar, so I can see the confusion there.
I was like, why did she just walk away?
Okay.
Mom wants to know if she can come to Calc today.
Sure, if she wants to be confused, just like her daughter.
Hey.
Damn.
Okay, number 10. Let's see, blah, 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 blah. Okay, they gave us the equation. So we're looking for clearly dx dt. So the first thing I would do is solve that equation for x. Do I need to do that?
Yeah.
Okay.
Yeah.
X plus x. So it's 1 over L x plus s. What's on the right hand side?
1 over
Equals
M.
1 over m times s.
It's a capital M, I think, right? It doesn't matter either.
Yeah.
Okay. But if we're looking for dx dt, so I'm going to just write that down at the bottom because that's so I know what I'm looking for. Clearly, I'm taking the derivative with respect to time, but I need to get x by itself, so I have just dx dt. So I would multiply through by L first, so I get x plus x is equal to L over ms. Subtract the s, you get Lm minus s. And now when I take the derivative, left-hand side's real easy. I believe L and M are constants, if I remember correct from the problem I did yesterday. Something's a constant somewhere. L and M are constants. So when I take the derivative, the only thing I'm taking derivative of are x and s. So we get that dx dt on the left is equal to L over M ds dt minus ds dt. Because our L and M are constants, they are not variables. Do not try to take a derivative of them. If you look at the answers, clearly there's no quotient rule, etc., etc. And then match it up to the answer. So O, D.
You could factor out the DSDT theoretically if we were continuing this problem.
Yes,
And then,
I
okay.
personally would have done it that way because
Yeah,
then
that's what
L
I
over
would.
M minus 1 is a constant, but
Yeah.
it's multiple choice, so that's why, like I kept telling you guys, you've got to be able to get it to their form, whatever their form is.
Okay.
So clearly, if you look at the answer choices, things to always point out, A and C could not have been the answer choices because they just left an S over to the side, didn't take those answers, so didn't take those derivatives, things like that. You should always be on the lookout for. Number 11.
Yeah.
Okay, so d dy dt. So, what is the derivative of x squared plus y squared equals 25?
2x plus 2yy prime
Okay,
equals 0.
that's good. We're trying to solve for y prime. So y prime is equal to negative x over y. And plug your numbers in. You're done.
Oh, okay.
Oh, you're taking it with respect to time. Deborah's derivative is wrong.
Well, I didn't read the problem.
This is what I get for trusting you. So somebody else explain what is wrong with that derivative.
It'd just be wrong. That's all it is.
It's actually only slightly wrong.
It'd be dy over dt, right then?
Close. You're breaking up, Bridget, but I think you were on the right track. Well,
Yeah,
what I
so
pieced together, there you go, much better.
oh, okay, it's like the 2x and then the dx over dt plus the 2, what is it, y dy dt.
Very good, that is exactly right. So Deborah's idea was correct, but she was taking her derivative with respect to x, not with respect to t. So we can't forget that every variable that is not t has a dx dt, dy dt, etc., etc. Now we can.
I forgot that.
So that's fine. So we're going back over it. Now we can plug in everything. They give us x, y, and dx dt. So remember, especially since multiple choice, I would not suggest solving for dy dt. Just go ahead and plug everything in. What was x again? I already forgot. Like 3.
3.
And then dx dt was 6, if I remember right. And then this
Yep.
was 4. So I would go ahead and just do this because especially since it's multiple choice, they're not asking you for a dy dt equation or anything like that. So just go ahead and plug everything in. So what is that? 36 over 8. So dy dt is negative 36 over 8 divided by 4, so negative 9/2. Yep. Okay, so that one's a pretty easy one. We just have to remember the whole dx dt, dy dt. Remember, that's why I told you guys it's really important to know what our derivative is with respect to. So all of these derivatives are with respect to time. So both x and y need the dx dt, dy dt, etc. Ooh, volume problem. Okay. Number 12. What 2 answers are guaranteed to be wrong?
Increasing.
Why increasing, Miguel?
Because it clearly says, where's it at? Water's leaking from the bottom of the tank. And if it leaks, how the hell is it going to increase?
That's a very good point. So yes, exactly. So we know it has to either be. Go ahead, Bridget.
Oh, I just said because it says leaking.
Oh, yeah. So definitely has to be A or D at that point. So the first thing is we now need a volume equation, which they're very nice and they gave us. So volume is 1/3 pi r squared h, in case you forgot. However, we have a problem with that. What is the problem with that equation as it stands?
You have 2 variables.
Very good. I have two variables, so I need to get rid of one somehow. So I'm going to need a secondary equation to sub one of those variables out. So 1/3 pi r squared each. So they probably give us a ratio somewhere. Let's see. The diameter is 10 and the height is 15. So they do. So they tell us that the diameter is 10 and the height is 15. Well, that gives us a ratio because if I take a cone, and this is going to be really bad.
Oh, the height 3 times the radius.
Something along those lines. Oh, actually, exactly along those lines, yes. So when we talk about that, if I take the whole thing versus a smaller one, like this, that is just like this portion, if I look at just that portion of the cone, these two will be similar. And that's not the right. It's only one, not approximate. So in case you don't remember, the tilde sign is just if you use one of them, that's a similar statement. So those two cones will be similar as long as I take one from the other. So this ratio will hold. And as Bridget already kindly pointed out, so we don't need the diameter, we need the radius. The radius is 5, the height is 15, therefore h is equal to 3r, or r is equal to 1/3 h, depending on which one we need. And that's where we'll sub out for our r or h. Which one are we looking for? The height. So if I want to have the height in my equation, I'm going to need to sub out r, so I'm going to have to use the r is equal to 1/3 h. So we now have a volume of 1/3 pi 1/3 h squared times h. So 127 pi h cubed. Once we get down to just the one variable, we can take the derivative of both sides with respect to time. So dv dt is 1/9 pi h squared times dh dt. Let's see.
Wait,
Go ahead.
that's the derivative. Oh, okay.
Yes.
Yes.
I'm trying to solve for dh dt, so now we can go ahead and start plugging everything in. They tell us that water is leaking at a rate of 12 cubic feet per hour. So what does that mean?
-12, I don't know.
Well, what's -12?
A rate. Oh, so you can plug it in for the whatever it is over dt.
DHDT.
But which one is
Isn't
the?
it dv/dt?
Why is it dv dt? There's a couple of reasons why we should know that.
Because the water is the volume.
Not just because the water's a volume. That's one reason. That's not the one I would say is the most obvious. How do I know it's a volume?
Isn't it in cubic feet?
That is correct. Cubic is a volume. Remember, so feet is linear, so that's just a measurement. Square feet's an area. Cubic feet is a volume. So when it says 12 cubic feet, that has to be my dv dt. And as someone already pointed out, Bridget, when she gave a wild guess, which was correct, it is -12 because it is leaking out. So the volume is decreasing. So then I can go, okay, 1/9 pi. Well, what's h? Do they give me h in the problem anywhere?
No, you have to solve for it.
Very good. Remember, most times you're going to solve for that extra variable. They do tell us that the volume was how much at the time? 27, I think.
Yes.
So if the volume's 27, you just solve for your h.
Wait.
Oh, no, that's 127. What, Deborah?
If the volume is 27,
Uh-huh.
oh, you said equal to the original. Okay.
Yep, plug that into the original equation here to find your height value.
Okay, so we can plug back in and find DHDT.
God, this is a ugly number. Yeah. So 27 squared over pi equals h cubed. So h is the cube root of 27 squared over pi, whatever that is. I'm just gonna.
It's
Then
27 pi equals 1 over 27 pi. Each of those.
hoo-ah.
The pi should have canceled. It should have been 27 pi.
Oh, is it 27 pi? Okay. That's the volume they gave us. My bad. But it won't cancel because it's 27. Oh, yeah, well. So, you're good.
Wait, I'm confused.
The volume they originally gave us is 27 pi, so the pi's cancel. And you get 27 squared equals h cubed.
Oh.
So then it's just 20, the cube root of 27 squared, which, I mean, still is not a pretty number. Actually, yeah, it
It
is.
is
It'll be, what, 9?
9.
Yeah. So 9 squared dh dt. And solve for your dh dt, which is not a pretty number at all. So that's what, 9, so negative 12 over 9 pi is dh dt. Morning. And that's what, 4/3. So the answer being D. Any questions on what I did anywhere? I know there's a lot. That's honestly one of the more involved problems in this entire section.
Were you like doing this on the whiteboard on Twitch?
Yeah.
Yes.
Mine is like, mine won't play. Like it starts to like play your stream, and then I think my Wi-Fi just says like no.
No.
Okay. I don't know what to
There's
say
not
to
really
that.
anything I can do about it.
It'll be on YouTube later,
Okay,
if anything.
cool.
Alright, number 13. Two roads intersect at right angles, cars traveling south. Okay, so two straight roads. Traveling south. I'm confused. Why do we need two roads?
Big mood.
There's only
I
one.
guess on this one.
They only use one road, though. I think.
It's probably just to set up the scenario.
Oh, it's a quarter mile east of the intersection. Okay. Okay, so it's basically just a triangle with a lot of really confusing words build up. One of the most convoluted ways to do this question I've ever seen. So, you got your intersection. The car is heading south, right? Car's traveling south, and there is a radar monitored a quarter mile east. Okay, so There's your sign. There's your car. Actually, I should put that on the other side. And then there's your car. The car is heading south. It says that the speed, the car is exactly a half mile from the sign and is decreasing at 60 miles per hour. Okay, so this is the scenario basically you have going on. It's a relatively easy problem once you can draw the picture, in my opinion. Getting the picture from this convoluted words is not so easy. So what kind of shape do we have?
A triangle.
Be more specific.
A right triangle.
Okay, now somebody else, what two equations are we going to use when we have a right triangle? One of two.
Is that a quarter mile?
Yes.
Oh god.
The a squared plus b squared thing.
The a squared plus b squared thing. That's probably the first time I've ever heard it referred to as that.
Pythagorean theorem.
There you go. What's the other equation we might possibly use?
I don't know, area.
Area?
Yeah, you're both right. So there's really three equations you can use. So you have Pythagorean theorem, which is a common one. You have the area, and you can also use a sine or cosine if they're talking about angles. This one clearly talks nowhere near about angles, so I'm not using any of the trig functions. So we just have to figure out if I want to talk about the area of the triangle or one of the side lengths. And they're asking about a distance, which is a side length. So I will definitely be using Pythagorean theorem. So a squared plus b squared equals c squared. So we know, I'm going to call this one A because I don't know it. This is B, and that's C. Okay. So we obviously are going to be taking derivatives of that because we're looking for the rate at which something's changing. So we can go ahead and take the derivative with respect to time plus 2b is equal to 2c dc dt. So just straight up take the derivative of it all, but being careful because we're doing it with respect to time. And then we just need to be able to figure out and fill in everything we know. So we are looking for the distance between the car and the intersection. So we are trying to solve for, in our case, dA dt. So we just need to go through and figure out, do we know everything else? So do we know our A value?
We can find it.
How can we find it?
Solve for A in the equation and
So-
plug in B and C.
Very good. Just like we did before, we're going to go back to our original equation up here and use our values. So maybe that off to the side. So a squared plus 1/4 squared is equal to 1/2 squared. Yeah, I can do that one. I'll just do 1/4 minus 1/16, which is 3/16. So a is equal to square root of 3/4. We square 3 over 4. Okay, so I can go ahead and plug that in. So I'm going to go ahead and cancel out all the 2's just because it makes my life easier. So I get square root of 3 over 4. I'm still looking for dA dt, so that one gets to stay. Do I know my B value?
1/4.
Do I know dB dt?
No.
Anybody else care to answer? I'll give you a hint. We do know it.
30?
Why would it be 30?
Because it's half the hypotenuse.
Okay, I see a thought pattern there. Not a good one.
Not a good one, but and I thought the other leg would do the same exact thing, and I realized I was wrong. I was like, well, no, never mind. It's a okay.
What do we know? What is B? What does B represent?
The distance between the intersection and the stop sign.
Well, radar sign, but that's fine. Um,
Whatever.
so
Oh, it's zero. It's zero.
why is
It's
it
not changing.
0? It's a constant distance. That one does not change. The distance between the sign is not moving.
Oh.
So that is 0. That's a constant. B is a constant value. And then our C we know is 1/2. Do we know dc dt?
I think it said 60.
Okay, so do we agree with Thomas? Is it 60?
I don't know.
Decreasing is 60 miles per hour.
So do we agree with Thomas? Is it 60?
Probably.
I'm gonna just agree because I really don't know.
And then I'm gonna need you to explain it.
It tells you that the distance between the car and the sign is changing at a rate of, or is decreasing at a rate of 60 miles per hour.
Yeah, I saw that, but I don't. How do I know which one that is?
Well, what's the distance between the car and the sign?
The
A, B, or C?
half mile. See.
C. So that would tell you dc dt is, if that value is changing at 60 miles per hour,
Oh, it'll be
What?
yeah,
negative 60.
a negative 60. Duh.
So they give you C. They do tell you that that value is changing at 60 miles per hour, but it is decreasing. In other words, it should be getting smaller. We don't need to hear you getting nice there, Miguel. So it is negative 60. You have to be careful on that. They do give you the value, but it's decreasing. So that goes away. So then dA dt, just solving that equation, so that's negative 30. So we get what, 120 over root 3, which I'm assuming they probably simplified that. Oh, no, they didn't. Okay, so 120 over square root of 3. So it's either A or B, and it's negative, so it should be B. You have to be very careful on when they give you information if it's increasing or decreasing with related rates.
How did you just like delete all of the twos?
I divided everything by 2.
No.
It's an equation. I can do that if I want to.
Well, can y'all shut up? Oh my god. But okay.
Any other questions on that one? Okay, number 14.
Wait, why is it the square root of 3 over 4?
Oh, I guess that one right too. Jesus.
Because when you take the square root of 3/16, 3 stays 3, 16 goes to
Oh,
4.
okay. I thought it was the square root of 3/4. My bad.
You're fine. Okay, so number 14.
Please explain.
Okay, so we talked about this before, so as a refresher, when you're talking about underestimates and overestimates, you're looking at how the curve is behaving. So you look at 2 things, increasing, decreasing, and concavity. So if I need this graph, linear approximation, if I want the linear approximation to be an underestimate, basically what I'm looking at, especially when picking out a graph, all you gotta do is ask yourself, is if I were to draw a linear approximation, aka a tangent line, would the line be above or below my curve? So if I look at A, clearly the curve is a line, so that's going to be an exact match. That's not what I'm looking for.
Yeah.
If I look at B and I draw a tangent line, would the tangent line we're looking at specifically at 2.3, so just to the right of that dot, if I drew the tangent line at that dot, would my tangent line be above or below my curve?
Looks like
What?
it'd be above, right?
Right, so and you can literally take your pencil and just make kind of your pencil like a tangent line. You should notice that the pencil or your finger or whatever you have that's straight would be above the curve. And that is not what we're looking for. We're looking for an underestimate, not an overestimate.
Okay.
And you
That
keep
makes
going. If you look at C, C will be the same way as part B. And then when you finally get to D, that tangent line at 2.3 will be under the curve, which means it's an underestimate.
Oh, okay.
Oh.
So that all has to do with if you look at both B and C, what do B and C have in common?
They're
Concave.
curved.
They are curved, and Thomas, what did you say?
Concave down, right?
They are concave
Yeah.
down. Then we get to the correct answer, D. What do we know about part D?
Gonna be
Up.
concave up.
Concave up. So here on this question, the concavity was the determining factor. And as again, you're making notes to yourself, because you should be doing this and having like a notes page, your underestimates and overestimates are definitely determined by concavity. You also need to ask yourself, does the increasing or decreasing part? So in other words, first derivative, second derivative. How do they affect it? But that's what you're looking at when you're looking at any underestimate or overestimate problem. You always need to mention one of those two, if not both, depending on the problem things. But that is a hands down, anyway, that's how we determine underestimates, overestimates every single time. So again, same kind of question on 15. So here, if I was you guys, as you're doing these types of problems, draw them. So the question is, does it depend on the increasing or decreasing part, which is A and B, or C and D, which is the curvature, is it curved up or curved down? As we just mentioned, the curvature is the part that's going to be the important ones for linear approximations. But what I would do is just draw out all 4 different types of graphs, an increasing concave up, a decreasing concave up, et cetera, and ask yourself which one is going to give me the desired result. So you can have an increasing concave down, you can have a decreasing concave down, you can have an increasing concave up, and you can have a decreasing concave up. So which one of these 4 graphs would get you the desired result? So does the increasing, decreasing part matter? Does the concave up, concave down part matter? Which one is going to get you what you want? So we want an overestimate. So when we look at that, the overestimate part, we're going to have to notice that it should be a concave down. Both the top 2 graphs would accomplish that.
So what did you say that the increasing and decreasing was decided by the first or the second derivative?
Increasing, decreasing is first derivative. That's the slope. The concavity is determined by the second derivative. Okay. So 15 will be C, because we need a concave down graph in order to be an overestimate.
Well, how do you know if it's going to be concave down or increasing or decreasing? Or, I mean, concave down, yeah, but how do you know which one to choose
So if
after that?
I look at the 2 graphs, because 2 graphs will always work, because it's either concave down, which is both of these, or it's concave up, which is these 2. If it was increasing, it'd be these 2, and if it was decreasing, it'd be these 2. So you're looking for the ones that matter. So if you draw your tangent line, which tangent line would give me an over approximation? And if you look, well, there's 4.
Well, the concave down ones.
So it's these 2. What do these 2 graphs have in common? Well, this one's increasing and this one's decreasing. So clearly that's a contradiction on that part. So that's not the important part. It's not an increasing or decreasing thing. So that's when we say, okay, it's down to they both, what do they have in common? And both of those are concave down. So as long as your graph would be concave down, you will get an overestimate in this situation.
But how do I know which one of those 2? Or does it?
It's both. They both are concave down. So if you look at the answers, concave down is the answer, so that's why it's answer C.
Oh, okay.
Now, if you were picking a graph, it could be either one of those.
Yeah, that's what I thought we were doing. Okay.
No, we're just picking what's the characteristic that causes it to be an overestimate, and that is concavity in this case. Okay, number 16 shouldn't have been too bad, I don't think, hopefully. Do we remember what our indeterminate forms are? Hopefully we do.
0
0 over 0 or
zero.
infinity over 0.
Right, we only use those. If you ever look them up, there are a bunch more that you don't ever use in Calc AB or BC. But there are other indeterminate forms, but those are the ones we're looking for in AB. We keep it to the basics. So you're just looking for which ones give you 0 over 0 or infinity over infinity. The one that doesn't is C.
It gives you like 0 over negative.
Yeah, because cosine of pi is -1. So they're basically testing a little bit of your trig knowledge of the basics and just knowing which ones. So, any questions on how any of those give you an indeterminate form that you want me to explain specifically? Oh, also on B, since I just saw it, you have to remember, like I've talked about, if you do ln of 1, don't forget that is 0. So that might have tripped up some of you as well if you didn't have a calculator or didn't use a calculator. Okay. 17. Do I need to do 17?
Yes.
God, you suck me go.
I don't know how I got that.
I'm sorry that I just don't know it.
You're good, buddy. You don't know what, Valeria?
No, I just didn't know how I got that wrong.
Oh, how you got it wrong. Okay. So, was it x cubed f of x, what?
Minus 54.
Over g of x minus 1?
Yeah.
Mm-hmm.
Okay. And we're plugging in 3, right? Limit is 3.
Yeah.
Yes.
Yeah.
Okay. So if you try to plug in 3, which should be your first try, you get 27 f of 3 minus 54 over g of 3 minus 1. I'm going to go on a limb and say that f of 3 is 2 and g of 3 is 1.
Yes.
So you end up with getting 0 over 0 if you try to do that, which means that I now have a L'Hopital's rule question. Remember, if you want to use L'Hopital's rule on a free response, you would need to show these limits out individually. This is multiple choice, so we don't have to do that. We just need to get to 0 over 0, and then I can do L'Hopital's rule. So I can now do the limit as x goes to 3. Take the derivative of the top. So this is a product rule. Got to be careful. So you get 3x squared f of x plus x cubed f prime of x. And then the derivative of the bottom is just g prime of x. I don't need a minus 1, so I could have centered that more, but whatever. And then plug in 3. So is it 27 f of 3 plus 27 f prime of 3 over g prime of 3. I know that's 2. So I get 54. What's f prime of 3? Somebody? F prime of 3?
Negative 4.
Negative 4. 80, 108. G prime of 3?
2.
2.
So negative 54 over 2, so negative 27. Does everybody follow what I did?
Yeah.
Yes.
Okay, looking at 18. They give us the graph of g of x and a tangent line. Especially when I notice this is now a limit problem with g of x and all that kind of stuff. That's going to lead me to believe this is a L'Hopital's rule question because they give me the function and the slope of the tangent line. I can figure out which is the derivative. So that's where I'm just assuming it's going to be that. So when I go to start plugging in, yes. So if you plug in 0 for x, you get g of 0 e to the 0 minus 3, and g of 0 is 3 because they give us that point. So you get 3 minus 3 on top, and on bottom you get 0 minus 0. So you get 0 over 0. So that is a L'Hopital's rule question. So pretty much same thing we just did, just different functions with our e's and things like that. So g of x e to the negative x minus 3 over x squared minus 2x. So since we got 0 over 0, we are allowed to use L'Hopital's rule, so just derivative of the top, derivative of the bottom. So top will become g prime of x e to the negative x minus g of x e to the negative x. The minus is there because when I take the derivative of e to the negative x, I get the extra negative, so be careful with that. And then on the bottom, you get 2x minus 2. And I'm plugging in 0. So when we do that, we get g prime of 0 times 1 minus g of 0 times 1 again over negative 2. So g of 0 is easy. They gave us that. That's 3. What is g prime of 0? Don't go all speaking at once.
Wait.
3. Maybe.
No, hold up.
I think
So how do we find, what does g prime represent?
the tangent line.
Less specific. What does g prime represent?
The derivative of g of x.
Okay, the derivative. What does g prime of 0 mean?
The slope of the tangent line at 0.
Okay, well, I wasn't expecting you to jump there, but yes. So g prime of 0 is the derivative evaluated at 0, aka derivative at a point, aka instantaneous rate of change, aka slope of the tangent line. So this is why I told you guys, like yesterday, those 4 like phrases, you've got to know they all mean the same thing. So as soon as I know I'm looking for that, that means I need the slope of that tangent line, which is positive 2. Okay. So very easy question if you know what that represents. So you get 2 minus 3 over negative 2, which is negative 1/2. If I did all my math right. Which I did not. I made a mistake somewhere. It's double negative on top. So it's positive.
Why?
2 minus 3 is negative 1. Because I can math. I promise.
Oh.
Big math.
Debatable.
Yeah, I just made all this entire course up for you guys the whole year. This is really fun. I just keep doing things. It's all wrong. Everything you've done is wrong. All those algebra steps I keep telling you guys are wrong. You're actually right on them. I'm the one that's wrong, you know.
We know.
Which means if you have an A, you need to be shifted to an F. And if you have an F, you're shifted to an A.
Good.
Heck yeah.
Oh, perfect. Well, I've got a B, so what does that mean?
That would go down to a D.
Oh, great.
So any questions on that one? Okay. All right, so a lot of you have started your FRQ, so I do appreciate that.
I looked at it and then I wanted to cry, so I closed the tab.
That's not a good idea. You do need to work on it. Also, I understand a lot of you don't want to talk or offer up your answers. Please make sure you're not just sitting there quietly, either A, going away from the keyboard or your phone or whatever and just logging in, or B, not paying attention or asking your questions feel free to ask them. Please ask them. Otherwise, this is useless for you to be here.
Yeah.
There we go.
So
What?
Yeah.